So I made a bit of a silly application, really. And there's a bit of a story behind it, and I've got a few practical tips to share that might be useful if you want to squeeze every single millisecond out of your application. A couple of years ago, I stumbled across Matt Westcott's JSConfEU, which was a Sinclair Spectrum emulator written in JavaScript. And I thought this was awesome, but I didn't really know any of the Spectrum games. So I kind of wanted to recreate it for one of my childhood consoles, which was the Nintendo Entertainment System. And this was my first big JavaScript project, really. Before I'd only done sort of little jQuery hacks and done some closure sin where I put millions of things in the closures, and I didn't really understand how JavaScript really worked. But I suppose you've got to start somewhere. And I had no idea how to make an emulator, so I thought I would find an existing one to port, or to at least get some inspiration from. Unfortunately, most of the existing emulators are written in C, and they use loads of sort of pointer magic to map bits of memory around. Now, this could be implemented in JavaScript, but it'd be incredibly inefficient. So I tried to look around for one that was in a sort of higher level language. Luck would have it, someone had written a NES emulator in Java, which was called VNES, and it's available at virtualnes.com, where he has a big library of games, and it runs inside the browser as an applet. Now, the nice thing about Java is that, well, the syntax of Java is actually fairly different, but the semantics of the two languages, as in what the code actually means, is actually remarkably similar. And this makes translating Java to JavaScript really straightforward. For example, this is a class in Java with a constructor function, and this is basically the same thing in JavaScript. We've just removed the constructor function and made it part of the function, which, if you like, is the class. This sort of thing, which is a class method. I basically did this by just writing a regex. It's really quite simple. I think I'm breathing into this mic. This sort of thing again. Thank you. This sort of thing, which is class properties. Again, it was basically a big regex to go through and replace all the sort of public ints with just var. Sorry, this dot, because it's on a function. And there were a couple of semantic differences, like this sort of thing, where JavaScript doesn't have integer division. So you had to explicitly say you wanted an integer. Because in Java, the int just typecast it as an integer. Now, on top of this, I just had to write the pixel buffer to a canvas instead of some Java applet thing, and attach a few keyboard events, and add a set interval to trigger the frame function 60 times a second. And that was pretty much it. I mean, most of those bits I just borrowed straight off JSConfEU, because it's the same kind of thing. And within a few days, I had a working emulator. Now, JSConfEU ran at full speed, but from the start, I knew that the NES was far more complicated. For example, the Spectrum doesn't have a dedicated graphics chip, but the NES does to generate sprites and stuff. So I really had no idea how fast it was going to run. And when I was writing it, there was no scientific process at all. I was just coding and praying. So I got it running. At the time, I was developing on Firefox 3, because at the time, Firebug was the best thing around. And it kind of worked. If we get Mario to move. It kind of worked, but it was a bit like Mario's on the moon. It wasn't really playable. This was supposed to be running at 60 FPS, and it was barely managing 10. Now, really interestingly, actually, it was like this across all the browsers. All the modern browsers at the time, anyway. Safari and Chrome both ran at about this speed. And being just a naive JavaScript developer, I just assumed that all JavaScript engines were built equal, and this was the fastest it could run, so I just sort of gave up. I actually didn't release it for 6 months because I thought nobody would want to play this. But anyway, so going back in time a bit, I first started this in December 2008, and then I released it onto the internet in June last year. And then a few months later, somebody I went to uni with sent me a patch. And all it did was replace this bit of code, which goes through every pixel in the buffer and writes it to the canvas element. You can see the screen is 256 by 240 pixels. And it replaced this with this, which all it's doing is exactly the same thing, except it remembers what the previous buffer was and only writes pixels to the buffer which have actually changed. And when you applied this patch and ran it in Chrome, it did this. It was running at full speed. And this is not the incredible bit. I mean, this is with a frame limiter that limits it to 60 FPS, or almost 60 FPS anyway. Without the frame limiter on, it was almost running double that speed. I had basically a 10 times performance increase just from this one tiny patch. And I mean, initially, I couldn't understand what the hell was going on. I mean, for starters, my assumption that all the JavaScript engines were built equal was just wrong. And not only that, I couldn't understand why Chrome was the one that went obscenely fast. So with a little help, quite ironically from a Mozilla developer, we basically found, I'm just going to stop these. We basically found that Chrome is just really, really, really fast. And at least at the time it was. At the time it was streets ahead of everything else. And the problem was that Chrome had a bug in writing stuff to the canvas, which is now fixed. But essentially by only changing what's changed from the last buffer, it was minimizing the number of writes it made to the canvas element, which essentially worked around this bug that made the canvas element really slow and let V8 just steam ahead and run at full speed. Now these sort of things are micro-optimizations, so they usually don't really matter for your applications. But when you have really, really tight inner loops, where every optimization counts, they really make a big difference. Like, for example, the NES runs at 60 frames a second, and for each frame, it's emulating 10,000 CPU instructions. And you can imagine how many times that function gets called, almost 750,000 times a second. So that function really has to be super optimized. Now, once it was actually playable, and it was out there on the internet, it got a bit of attention on Twitter and the blogosphere and stuff like that. And somebody from Apple came along to try and figure out why it was so slow in Safari. And it turns out it was actually a really simple problem. Safari had a problem caching really large objects, which JSNez was full of. But I'm happy to say that this is now fixed. It's not quite as fast as Chrome, but it still runs the emulator at full speed. And a few Opera people have pointed out that their browser's pretty fast too. But unfortunately, Firefox is still really slow. And you saw how fast it ran in an old version earlier. And it isn't much better on a recent stable version. And it's basically a problem with how Firefox traces code. Where it tries to tracing is where it tries to figure out how a path of code is going to run. But because with an emulator there's so much branching, where it branches to different things for different instructions, you have what's called, I think it's a branching explosion or something, where it just can't figure out what's going to happen in these branches, and then it just gives up and falls back to interpreting the instructions one by one. That might be wrong, but that's the impression I got. But credit to them, though, they're trying to fix this. And on their Yaga Monkey engine, this is a recent build of it. It actually, at least on my little laptop, it's almost full speed, and I've heard it runs at full speed on faster computers. And they've yet to improve on this. I think they're going to merge two branches or something to make it doubly fast, but I'm not sure what's going on, but it's going to be really fast. Now, I did try it on Internet Explorer 9, and it did run, but I left it running for about an hour on my benchmark, and it just didn't do anything. So I'm not sure whether that's a problem with Internet Explorer or my benchmark, and it'd be great to talk to some people from Microsoft about this, but in theory it could work on Internet Explorer, I'm just not sure how fast it is. Now, a useful performance tip, which you probably already know about, it's another micro-optimization thing, which is using prototypes. For example, in this top one, every time that a new instance of tile is created, it creates a new render function. But in the second example, it always uses the same render function from the prototype. And this can be significantly faster when you're creating loads and loads and loads of objects. I'll put this code up on the web sometime afterwards if you want to copy and paste code. Now, when I was cleaning up my code to put everything into prototypes, I stumbled on a really, really annoying bug in Chrome. And this one took me days to fix. Essentially, as a sort of hangover from the Java port, I had a load of variables declared in the constructor, like this. And then I called a reset function, which actually assigned them a value. So I could reset the object without having to reinstantiate it. And obviously, this is a bit pointless because I'm defining those properties anyway. So surely I might as well just take away those properties that equal null, and it'll do exactly the same thing. It doesn't at all. The performance on Chrome dropped to around 20 FPS. Just Chrome, none of the other browsers. I mean, even Safari ran at full speed. I'd somehow killed this bit of magic that made Chrome run really fast. And because I was doing it as part of this sort of big refactoring of the prototypes, I was convinced it was something to do with this, and I just didn't consider removing those nulls would actually do anything. And it turns out it's to do with how V8 represents objects. Objects in V8 are backed by things called hidden classes, which are a bit like classes in Java. They essentially define what properties are on an object. So when you need to look up a property from an object, it knows the position of that property from the start of the object in memory, and it can do a really fast lookup. Like, I think it's sort of 3 lines of machine code or something. But JavaScript's a dynamic language, so you can add and remove properties at any time. So when you add a property to an object in V8, it takes away the hidden class that's already on the object and adds a new hidden class with that new property added. So I'm guessing by not defining these properties in the constructor, it was just sort of switching in and out hidden classes as I added extra properties. Or maybe it even wasn't using hidden classes at all and just doing slow lookups on the properties. I don't know. But it was something to do with that. It was something to do with Chrome's hidden classes. So the lesson is, I suppose, always declare your properties in the constructor. Otherwise, Chrome might do something weird. Now, another neat thing, which might be helpful, is a benchmark I wrote that it essentially runs 50 frames of an open source homebrew ROM and times it. And here are some completely unscientific results that I put together on the plane here of some of the latest browsers. You can see Chrome on the left is really, really fast. Safari is slightly slower. And then Opera 10 is about twice as slow as Safari. And then Firefox is a lot slower. But this is kind of unfair, because Firefox are going to improve their engine a lot. This is actually the latest build of the Yaga monkey stuff. But I think they've yet to get this faster before the actual official release of Firefox 4. This is available on my GitHub account. And I think it's being used on the Yaga monkey engine at the moment on their arewefastyet.com or something like that. And if anybody else wants to use it, please do find me afterwards, because I'd love to make it something that's useful. One of the things that was really, really hard to get right was accurate timing in Firefox, which is quite important for an emulator. Originally, I was just using a set timeout that called the frame function like 60 times a second. But this is incredibly inaccurate, and all the games were just really jerky as the browser sort of decided, oh, I'm going to take up some more CPU time, and the emulator just sort of stalled for a little bit. The method I eventually settled on, after trying a few other ones, is using a set timeout, but making it fire really early, and then just sitting in a while loop until the right time to display the function. Display the frame, sorry. It's really, really inefficient, but it kind of works. It's incredibly accurate, actually. Essentially what it does is it renders the frame, and then waits until the right time to actually display the frame, then writes it to the canvas, and then triggers the next frame sort of half the time too early so it can render the next frame. If somebody has a better solution, I'd really love to hear it, because I don't like this solution at all. One of the other shiny things I worked on was sound, and this is really cool. For a while, you couldn't write dynamically generated sound to an audio element. So I wrote a tiny little 1-pixel Flash application which read a buffer from JavaScript and then wrote it out to the speakers. More recently, Mozilla have developed their audio data API, which is only supported in Firefox, which is frustrating. But it lets you read and write audio samples directly to the audio element, which lets you do cool visualizations and synthesizers and stuff like that. So I wrote this little, using the Flash application I'd written before, I wrote this little library. Essentially, it uses Firefox's API if it's available, but it falls back to a little Flash widget if it needs to. So it's essentially backwards compatible back through, I haven't tested it, back through sort of Internet Explorer, but it will probably work on really old versions. And that's pretty much it. I suppose there's time for questions, because Tobias couldn't make it. Yep. Oh, right. Ah, okay, that's interesting. Yeah. Oh, I see. Okay. Yeah, because you could tell when you were playing the game that it just sort of sped up and then slowed down and then sped up and slowed down. That'd be fantastic. I heard there was a hack where you could attach something to the window object to get around set timeout 0 not actually being set timeout 0. I don't know if that works. But no, that'd be really interesting. Thank you. Yes?
Did you find that moving methods onto the prototype made a difference?
It didn't really make much of a difference in my case because I instantiated all the objects before I started. But I've run a few benchmarks about that, and it's about 3 or 4 times faster, I think. So if, on an inner loop, if you're creating loads and loads of objects, it's probably worth it. I just did it to make tidy code. But yeah, that's... Yes? With the what, sorry? Oh, yes. Oh, okay. What should I use instead? Ah, okay, yeah. Thanks for the tip. Anything else? Cool. I guess that's it.